Hello everyone, myself Arshit. Teammates are Daksha, Deepa and Ishita. Our topic is to read the digital and analog values using IR sensor. So the apparatus required to do the project is IR sensor, microcontroller as Arduino and connecting wires and jump wires. So now I'm gonna explain about IR sensor. So IR sensor typically consists of IR LED and photodiode, where IR LED emits infrared light, which is not visible to human eyes, and photodiode, which detects the reflected IR light. The operation of IR sensor is when an object is placed in front of the IR sensor, the IR light emitted by the LED reflects of the object and is detected by the photodiode. The sensor circuit amplifies the change in circuit current or voltage caused by the reflected IR light. This change is used to switch the digital output from high to low or vice versa depending on the configuration. Let us see the observations of IR sensor. When the sensor is placed 20 centimeter above, the output will be 5 voltage high and the object detection will be absent. When the sensor is placed 10 centimeter above, there will be 0 voltage low and the object will be detected. And when the sensor is placed 5 centimeter above, the object output voltage will be 0 and the object detected is detected. And the analysis of IR sensor is as the object moves closer, the amount of reflected IR sensor increases. The sensor is most effective within a specific range, usually 2 to 20 centimeter for basic models. Or outside this range, no reflection is detected.
I'm going to explain about Arduino Uno. Arduino Uno is one of the most popular and widely used microcontroller boards in Arduino family. It's a great choice for beginners for working on electronics and embedded system or projects. Here is about Arduino Uno working in this project. Analog reading. The analog pin reads the voltage from IR sensor. The value typically ranges from 0 to 1023, representing 0 to 5 volt. Digital read. The digital pin reads from high to low based on the weather. IR sensor detects an object. Processing. Arduino process and logs both values. Display. The readings are sent to the serial monitor.
Procedure reading the digital values. Steps connect the digital output of IR sensor to pin D2 of Arduino. Open the serial monitor. Place an object in front of the IR sensor. The output will be object detected. High, low, no object detected. Use this code.
Code explanation. Const int proxy sensor is equals to 2. This means a constant integer variable named proxy sensor and it assigns the value to. Int input value is equals to 0. This means a integer variable named input value and it initializes it to 0. Void setup is a special function that runs once when the Arduino board starts up. With pin mode 13, output. This sets the digital pin 13 as an output, and then on board LED connected to it on most of the Arduino boards. Pin mode proxy sensor input sets the pin defined by the proxy sensor as an input. Serial dot begin 9600 initializes a serial communication at a band rate of 9600 bits per second. Void loop is another special function that runs repeatedly forever after setup finishes with if statement and then a digital write 13 comma high if the if condition is true. This line turns the LED connected to the digital pin 13 on. Else, if the condition is false, no object detected. Next, if the digital write 13 low, this line turns the LED connected to the digital pin 13 off. Input rail is equals to digital read proxy sensor reads the digital state of the proximity sensor again and stores it in the input rail variable. Serial dot print input rail prints the value of the input rail, which will be 0 from low or high from high for 1 for high. Delay 1000 pauses the program execution for 1000 milliseconds. This means the sensor is read and LED state is updated once every second.
Reading analog values. Connection IR sensor analog out. VCC Arduino 5 volt. Ground, Arduino ground steps. Connect the IR sensor to the Arduino as per the connections above. Open the Arduino IDE on your computer. Copy and upload the following code to the Arduino. Go to Tools, Serial Monitor. Observe the analog values. Change as move on object closer or further from the sensor. Note the closer objects or white surface reflect more IR and give higher values, while further or black surface give lower values.
Code explanation for analog. Const in proxy sensor is equals to AO. This line defines proxy sensor as AO. Void setup, pin mode 13, output, and serial dot begin 9600 are same as in the first code explanation. Then pin mode proxy sensor, input. While pin mode can be used with analog pins, it's generally not strictly necessary to declare analog pins as input when using analog read bracket. Void loop. If digital read proxy sensor is equals to 5, this part of the code is problematic or at least potentially confusing when proxy sensor is AO. Digital read AO will treat analog pin AO as digital pin. If the voltage on AO is above a certain threshold, digital read will return high, otherwise it will return low. So even though the sensor is connected to an analog pin, the LED control logic here is still based on some simple high or low threshold. Digital write 13, high and digital write 13, low. These lines control the LED based on the digital read of AO, just like before. Input value is equals to analog read bracket proxy sensor. This line is a key difference. This has a key difference. Analog read reads the analog voltage on pin AO and converts it into a digital value ranging from 0 to 1023. 0 corresponds to 0 volt and 1023 corresponds to 5 volt. This value represents the strength or distance detected by an analog proximity sensor. Serial.print ln input rail prints the analog read value from 0 to 1023 to the serial monitor. This provides much more granular information about the sensor's output compared to simple or one form digital. Delay 1000 pauses for 1 second.
So let us come to the conclusion of the explanation. So the experiment demonstrates how to read and interrupt digital and analog values using IR sensors. So the results can be using various applications like object detection and line following robots. So thank you.